1G.
1G, which ran merely on 2.4 kilobit per second, was introduced in the 1980s. It made use of analog signals which has low data transmission rate and low coverage distance. Let's move on to 2G.
2G.
Moving on to 2G, 2G has a speed of 64 kilobit per second and it uses digital signal. Therefore, it can cover long distance transmission. However, the signal could be weak in rural areas and video cannot be supported.
3G.
3G, running at 2 megabit per second, came into place when higher transmission rate was needed. But the problems were expensive 3G licensing and the challenges that came with building 3G infrastructure.
4G.
4G has speed approaching 100 megabit per second. It has higher capacity and higher security, but it was hard to implement and need complicated hardware. The bandwidth channels are almost used up and it has a high latency of 50 milliseconds.
5G.
5G, a complete wireless communication with almost no limitation and highly supportable to wireless World Wide Web. Its speed is 20 times faster than 4G. 5G also has faster data transmission than any of the previous generations.
In this video, we thought of 3 ways on how to make 5G more efficient in assisting our product to help disaster victims. The first one will be the folding table. As shown in the diagram, the folding table 1 in a router are connected to the folding tables in another routers. That is folding table 2 and 3. In 5G, if the connection is lost between the current router and the destination, which in the diagram is from folding table 1 to 2, the folding table 1 will rapidly find an alternative path by using the routing protocol or routing algorithm to calculate the shortest path to reach the destination, which is folding table 2. The router that contains the folding table 1 will first go to the nearest connected router, which is folding table 3, and then follow the path until it reaches the desired destination, folding table 2. The recovery time depends on the number of flows to be routed, and since 5G has a low latency of 1 millisecond, packets can still be transmitted fast enough to its destination with minimum congestion.
Same as the forwarding table concept, for 4G, the house routers are all connected to a single nearest 4G mobile base tower which provides them internet access. But when there's natural disaster like the typhoon or tornado or even earthquake, there will be a very high chance of cell tower being destroyed, and when that happens, the house routers that are connected to the cell tower will all lose its connection and unable to connect to the internet. Therefore, it will be harder for the victims or even civilians in that area to contact the authorities. But with 5G, multiple small cells that can be placed on places such as on top of a lamppost are set up in each areas. Due to 5G's millimeter waves, the small cells are able to cover 250 to 300 meters. So, when natural disaster strikes, there will be no fear of losing connection as there are many other nearby small cells that are still working to connect to. Therefore, connections can still be established and information can still be transmitted rapidly.
So, in our 5G plan, the device-to-device communications will be included in. It is a type of peer-to-peer link that enables direct linking of a device or user equipment UE to another person's device via cellular infrastructure. In the example shown, there is one base station along with user equipments 1, 2 and 3. UE1 has cellular connection with the base station, while UE2 and 3 shows device-to-device communication. This allows large volumes of data to be transferred between UE2 and 3 over a close proximity through direct connection without the need of routing through the core network or base station in this case. During disaster, survivors or emergency workers could communicate efficiently with one another with lesser delays. And now, we will present the role of multi-hop links in D2D communications in times of disaster. The example shows 3 different layers of coverage, the first being covered area, followed by extended coverage area, and finally the out of coverage area. There will be a base station across the place, and inactive ones on the left and right corner will signify possible destruction by nature. Not forgetting, several UEs spread across the area of disaster too. At first, the active base station will communicate with nearby UEs in the covered area, which will then follow up with other UEs in the extended coverage area. In cases where a UE is situated at the out of coverage area too far from the base station, other UEs can serve as relays to connect it to the base station. This multi-hop link is able to increase cellular coverage areas besides overcoming obstacles in between to help in finding survivors around the area.
On to the transport layer. When natural disaster strikes, most of the victims will try to contact their family either through phone calls or the internet. But since circuit switching was completely replaced by voice over IP in 4G, the network will be congested with spikes of outgoing calls and victims trying to access the internet. To solve this problem, multiple TCP congestion control algorithms such as the TCP Reno has been implemented. But with our current 4G technology, our ping lies around 20 to 50 milliseconds and might rise exponentially according to the traffic intensity. But with 5G, it is possible to reduce that latency to as low as 1 millisecond, which means sending 70 packets through the network which used to take around 300 milliseconds can be reduced to 12 milliseconds. The low latency of 5G benefits users by being able to send and receive information faster, especially when natural disaster happens. Besides, part of the reason why the traffic intensity during disaster is high is because the RWND is equally distributed. This is why instead of sharing the RWND equally to everyone, the RWND should be adjusted so that it reserves more resources for the rescue team and victims, and less for normal civilians so that the RWND can handle more arriving packets from disaster areas. Similarly, the CWND of both the victims and normal civilians should be adjusted accordingly for better utilization of the reserved RWND.